For today's video we're taking a look at and repairing a Monroe 525 desk calculator from the late 1970s. Monroe started making mechanical calculators in 1912 and is still making office calculators to this day. I'll put a link on screen to one of my other videos featuring a 1950s Monroe LN160X mechanical calculator. My 525 was made in Japan in the late 70s for Monroe, who were based in America. At that time, Monroe was owned by Litton Business Systems Incorporated. The Monroe 525 has a bright and clear 12-digit vacuum fluorescent display and keys that have a good solid feel when pressed. On the rear there's a standard C13 power socket, which is quite chunky considering the machine only uses 2.6 watts of power. You can still see the original dealer's sticker, John Maybon Associates Limited, of the Bullring in Birmingham. On the right hand side is the on and off switch. As was common at the time, this machine came with the dust cover. They were expensive machines and you were expected to cover them when not in use. Machines in those days were built to last and not be thrown away after a couple of years of use. When I bought this machine, it appeared to be working fine. It wasn't until I actually tried to do some calculations that I noticed I was getting some very odd results. After a little bit of testing, it became apparent that some of the keys were intermittently giving more than one trigger from a single press. If you take a look at this clip where I'm trying to add 300 several times, with just 5 presses of the plus key, I've reached a total of 3600, when it should be showing just 1500. Similarly, when I try to repeatedly multiply 2 by itself, after 7 presses of the multiply key, it's reached a total of 4096, when it should be showing 128. I'm deliberately pressing the keys slowly for this demonstration because that accentuates the problem, but it still happens regardless of how hard or fast I press the keys. So the machine needs to come apart for some more investigation. Hopefully it will be possible to take the individual keys apart so I can clean the electrical contacts. So we'll start off by removing the 4 screws that hold the 2 halves of the case together. And then we'll flip the machine back over and remove the decimal point selector knob before lifting off the top half of the case. And while we've got the machine apart, I'll brush off some of the dirt that's accumulated over the years. The keyboard is connected to the motherboard by a multi-way socket, and there's also an earth wire to the chassis, which appears to be pretty tight, so I'll deal with that a bit later on. So now I can carefully ease the connector apart and then lift off the keyboard section itself. Each key is held into the upper plate with a plastic clip at each side, and then the electrical connection is soldered to the circuit board beneath, so I'll need to remove the solder before unclipping each key. I'll start off with just one key to make sure they can be fixed before I take the whole thing apart. I'll use my solder sucker to remove as much solder as possible, and then remove any remaining solder using desoldering braid. Once the solder is removed, I can release the retaining clips and remove the key for inspection. And here is the first key in pieces. The lower half has the fixed contacts, and then the moving plunger section has a little spring that fits inside a slot. It's the side of this spring that wipes across the lower contacts. It's more than a little bit fiddly to refit the spring. It's intended to curve outwards because that's how it makes the contact with the fixed section. So I'll need to come up with a better plan to reinsert these springs before I actually take the rest of the machine apart. Having reassembled and refitted the first key, it was working perfectly. So I'll now carry on and do the remaining 23 keys, one at a time. While I'm doing the rest of the keys, we may as well have a slightly more detailed look at the process. Having desoldered the electrical connections, the key can be released from the upper plate by pressing the plastic clips with the screwdriver like this. Then, to take the key itself apart, the sides can be gently prised open to release the plastic clips. Once both sides are released, the bottom section can be carefully lifted off to reveal the plunger and spring inside. Once apart, I'll clean both parts with alcohol. The spring and the contacts appear to be gold-plated and are still in good condition, but there are some traces of dirt on my cotton bud after cleaning, so it's pretty likely that the dirt will have been the problem. Well, that took quite a while, but here's the last key being soldered back onto the circuit board, and then we can get on with demonstrating the calculator. So now everything's reassembled, let's have a little demonstration. If you've not used a desk calculator before, they can seem a bit strange at first. If you try adding 12 plus 10 in the way you would on a pocket calculator by pressing 12 plus 10 equals, you get an answer of 10, which might come as a bit of a surprise. These machines work like a mechanical calculator. Entering a number does nothing until you add it to the register with the plus key. So to add 12 plus 10, you have to type 12 plus 10 plus to get the answer of 22. Then if you want to add another 10, you just press the plus key again, in the same way that you'd crank the handle on a mechanical calculator. The multiply and divide keys do, however, work like a pocket calculator, so if you want to multiply 27 by 56, just type in 27 times 56 and equals, and you'll display the answer of 1512. Below the display is the decimal place selector switch. You've got the add mode, where the machine works like an adding machine, and then the floating decimal point, 0 decimal places, 1, 2, 3, 4 and 6 decimal places, depending on what you're working on. In add mode, you can type the number without pressing the decimal point. So to add £12.99, you can type in 1299 and hit the plus key. So if we want to add £12.99 and £4.99 and £2.50, and then we want to add two lots of £5, we can save a keystroke by entering 5 followed by the decimal point rather than 5 and 2 zeros. And then for the last 5 you can just hit the plus key again, giving a total of £30.48. In floating point mode, the decimal point can be anywhere on the display. This is best for division and multiplication. So if we divide 355 by 113, we'll get the answer 3.14159292035, which is an approximation of pi. Pi itself would of course be 3.14159265359, but you probably didn't need to know that. Moving the switch into the 0 decimal places position only gives whole numbers in the result. So if we add 4.546 and 3.142, it shows the full answer of 7.688 until we press the equals key, at which point it rounds the answer up to 8. And moving on to the 1 decimal place position, if we do the same sum of 4.546 plus 3.142, again we see the full answer of 7.688 until the equals key is pressed, when the answer is rounded to 7.7. Next is the 2 decimal places position. I prefer to use this if I'm adding money rather than the add mode, probably because I'm more used to entering the decimal point as I type. If I do the same calculation that I did in the add mode, there's an extra keystroke for the first 2 numbers, but then you save a keystroke on each of the last 2 numbers. So on this particular calculation, it ends up with the same amount of key presses. But if you have a lot of numbers that aren't whole numbers, you can theoretically enter the numbers quicker using the add mode. The calculator has a memory function with a fairly standard memory plus, memory minus, memory subtotal and memory total keys. The memory total also clears the memory. So let's say we want to work out 37 times 8 minus 63.5 times 4. We can do the first multiplication, so that's 37 times 8 and equals, and then add that into the memory using the memory plus key. And now you can see there's a letter M on the display to remind you that there's something in the memory. And then we can do the second half of the calculation, so that's 63.5 times 4 and equals. Then as we want to subtract this from the main total, we press the memory minus key. And now to see the result, we press the memory subtotal to reveal the answer of 42. If we now clear the screen, you can see that the letter M remains because our 42 is still in the memory. To clear the memory, press memory total, and now when you clear the screen, the memory is empty. It's fairly normal practice to press the clear key and the memory total key a couple of times before you start a calculation. This ensures that there's nothing lurking in the main register or the memory that could affect your calculations. So next we can take a look at the percent key. Let's say we've got an item that costs £119 excluding tax, and we want to work out the cost including 20% tax. So we enter 119 times 20%. This shows £23.80, which is the 20% of tax. Then if we press the plus key, it adds that to the cost to give £142.80 inclusive of tax. Similarly, if we have an item that usually costs £89.99, but we want to do a special offer and reduce the price by 15%, then we can enter 89.99 times 15% and press the minus key to give the result of £76.49. At this stage we can subtract that 15% again by pressing the minus key, or with 2 presses of the plus key we can return to the start price. If we wanted to add another number to the total once we'd taken the 15% off, we'd need to press the equals key first, and then press the plus key to add that total into the working register. And now we can add another number to that amount, say £40, giving a total of £116.49. Another thing we can do with the percent key is work out what percentage one number is in relation to another. Say for instance that last year it rained on 219 days and we want to work out what percentage of days it rained last year. So we can enter 219 days that it rained divided by 365 days in the year and press the percent key to show that it rained on 60% of the days last year. And now for something a little bit more complicated. You can use the memory and the main register to add up 2 different sums at the same time. So let's imagine I'm running a stall at a craft fair. I'm selling paintings for a friend and I get to keep 25% as my commission. And I'm also selling my own photographs, but I have to pay 15% of my own takings to the organiser. So I've got 2 columns of figures with paintings on the left and photos on the right. I can add each painting into the main register using the plus key and each photo into the memory using the memory plus key. So we've got a painting for £60 and a photograph for £20 and a painting for £35 and a photograph for £40 and a painting for £18 and a photograph for £15 and a painting for £27.50 and a photo for £38 and a painting for £48 and a photo for £12 and a painting for £50 and a photo for £25.99 and a painting for £25 and a photo for £12 and a painting for £18 and a photo for £12. Okay, that's everything added up. So now you have to deal with the main register first. There isn't a way to reveal what's in the main register without adding something else into it. So if I add 0, it won't change the total, but it will now display that total. So now with this total I want to work out my 25% commission, so it's times 25 and percent, which shows me my commission of £70.38. If I now press the minus key, I can see the £211.12 that I'll pay to the artist. I need to write down these figures because the calculator won't store them for me. So now I'm done with that side of the list, I can clear the screen and then use the memory subtotal to display the other total of £174.99 for the photo sales. Now I need to calculate the 15% that I need to pay the organiser, so again it's times 15% to show the £26.25 that I need to pay out. And then if I press the minus key, it'll show what's left for me. Finally, I want to work out my overall takings for the day. As with the percentages we looked at earlier, I need to press the equals key and then the plus key to add the current total into the working register. And then all I need to do is enter the £70.38 commission that I wrote down earlier and hit the plus to give my takings for the day of £219.12. And now for a little exercise using the equals plus and the equals minus keys. Imagine a customer has ordered 20 items costing £10.99 each, and 50 items costing £2.99 each, and they've returned 8 items that they didn't need costing £6.99 each, which are subject to a 20% restocking charge. And finally there's an £18 delivery charge. If we enter the 20 times 10.99 and then press the equals plus key, it will show the total of that calculation and add it into the memory, and as before the letter M will show in the display. Next we can enter 50 times 2.99 and again press the equals plus key, which shows the total of that calculation and adds that into the memory as well. Now we can enter 8 times 6.99 for the items that have been returned, but this time we don't want to use the equals minus key, so we just press the normal equals key. And we want to take off the 20% for the restocking charge, so we enter times 20 and percent, and then the minus key to subtract that 20%. Now we can use the equals minus key to subtract this amount from what's left in the memory. Finally, we can enter the £18 delivery charge and add it into the memory using the equals plus key. Now all we need to do is display the memory using the memory subtotal key to show the total invoice figure of £342.56. Not forgetting at the end to clear the memory once everything's finished. And of course there's still the big question. What happens if I try to divide by 0? There are all sorts of stories about old calculators catching fire when you try to divide by 0. So if I enter the number 1 and then the division key and finally press 0, do I really want to try this? Well, here goes. Equals, and you just get a letter E to show that there's an error. So yeah, they've thought about that. There's probably loads of functions I haven't thought about for this calculator. If you have any suggestions, put them in the comments and maybe I'll do a part 2 video sometime. But for now, I think this video has gone on plenty long enough. If you've enjoyed watching, please like the video and subscribe to the channel. There'll be more vintage stuff and repairs coming soon. So thanks for watching, and I'll see you in a future video.